I have two questions here. First, just to revise what is linearity means. Question for Mohammed. You know, systems are classified into two, linear and nonlinear. Why we need to classify? Because the type of process, the type of mathematical modeling we use for linear systems is totally different with nonlinear systems. We can apply convolution for linear systems. We cannot apply convolution for nonlinear systems. We can apply differential equation analysis for linear systems. For nonlinear systems, we have another method, what we call it a state space analysis. So the analysis processing is different for linear systems and nonlinear systems. That's why we need to classify systems into two broad categories, linear and nonlinear. So it's very important how we define linearity. If a system is called linear, it must satisfy two conditions: superposition and superposition and homogeneity. Let's discuss first superposition. Superposition means take a system, discrete time system, apply input x1n, it generates output y of n. Apply another input for the same system, apply another input x to n, it generates what? Another output y to n after processing. You know what processing means. So after processing, it generates two outputs for two individual inputs. Now what will happen if you add these two signals together, x1n plus x2n, and apply together? Here we apply them individually. What will happen if you apply them by adding the two? If you add these two and apply to the system, if the output is the summation of the two outputs, y1 of n, y2 of n. If the input is x1n and x2n plus x1n plus x2n, if the output is the summation of the two individual outputs, we call superposition principle, right? Summation. Homogeneity means multiplication by a constant. If x1n generates what? y1 of n. If you multiply it by 2, the only effect on the output is also multiplied by 2. If you multiply it by 4, the output also will be multiplied by 4. Then we call it homogeneous. Okay? That's what we call it, homogeneity. Now, if you combine these two, as you can see here, we multiply this input by a constant, which is homogeneous property. We add the two, it's called superposition. So what do you expect if a system is linear here? What do you expect here? y1 of n multiplied by a, y2 of n multiplied by b, because it is homogeneous, plus the two summations because it is superposition. So in that case, the system is what we call it linear system. As you can see here, if y3n is equal to, the first condition is homogeneity. If you multiply this by a, output multiplied only by a, no other change. If you multiply this by constant b, the output also multiplied by constant b. That's homogeneity means. If you add them, the output also will be added together, as you can see here. The addition is superposition. Multiplication by a constant is homogeneity. Combine the two, we call it linear systems. Okay? And is it clear? Is it clear?
Sharmake.
Yes, now it's clear.
Clear?
Now it's clear, teacher.
Okay. So we discuss linearity. The first property of discrete time signals. Okay, second important property of discrete time systems. Again, this property is very important. We call it time invariant versus time variant. So again, just like linearity, discrete time systems also classified into two. Some systems are time variant, some systems are time invariant. So what does it mean by this? So let's see. We call a discrete time system time invariant if it satisfies the following condition. How to check your system is time variant or not? Not variant, time invariant. So let's apply one input. Always here we are talking about discrete or digital inputs and outputs. So we apply x1 of n as input. As you can see here, it generates output y of n. Okay, y1 of n for input. Now, next, shift the input by some amount of k. Delay the signal by 2 seconds or 3 seconds and apply to the same system. Then check the output. Compare the output with the previous output. The previous output, when you apply x of n, we get y of n, right? Now shift the input and check your output. When you shift the input by some amount of k, what is the effect on the output? If the output is only shifted by the same amount of k, as you can see here, when you shift input, output also what? Shifted, no other effect. The waveform, the amplitude, everything, frequency, everything is the same. The only change when you shift input signal or delay a signal by some time, the output also will be delayed by that amount. No other effect. The waveform, the amplitude, frequency, no change. Such type of systems, we call it time invariant systems. It's very important classification of systems. Again, when you come to the processing, type of process we apply for systems is different. As I said, differential equation modeling, we use it for linear systems. When you come to nonlinear systems, it's called a state space analysis. So it's totally different. Differential equation modeling cannot work for nonlinear systems. So it's very important to identify the properties of our systems. So time invariant system, how we define it? If input is shifted by some amount of k, the only effect on the output is also shift by same amount. You can read it here. Time invariant system is also called shift invariance because shifting the input by some amount of k, causes only what? Only shift of the output by the same amount, no other effect. But when you come to time variant systems, if you shift the input, the output will be totally different. The waveform frequency changes. Okay? So, but when you come to time invariant, when you shift the input, the output only shifted by the same amount, no other change. That's what we call it time invariant and variant. So, is it clear?
Yes, it's
Okay.
Any question you can ask.
Okay.
It's clear.
It's clear?
Yes.
Okay. Now we have discussed so far two properties, right? First property we discussed is what? Linearity. The second property we discussed, time invariance. Now there are again now combine these two, linearity and time invariance. Systems also broadly classified into two. This is very important classification of system, as you can see here. What it says?
Okay.
It says what? Linear,
Linear.
linear,
Time invariant.
time invariant. Linear time
Yes.
invariant, which means a system which satisfies both linearity and
Different.
time invariance. Both. Some systems can be linear but not time invariant. Some systems can be time invariant but non-linear. But there are specific type of systems satisfy both these two conditions.
مش ما ظهر لي هذاك.
Linear
Okay.
plus linear plus time invariance. Linear plus time invariance combination. We call these systems LTI systems. Very important class of systems. Will come when you come to the processing. We'll see these systems again. So, if a system is linear, it satisfies what? Superposition and homogeneity, but it is not time invariant, it is time variant. So we are not saying it is LTI system. To say a system is LTI, it must satisfy both two conditions. It must be linear and it must be time invariant. Then this class of systems, very important class of systems, we call them LTI systems. Okay. Third property, stability. Here, it's very important concept, stability. So what does it mean by, again, systems can be stable or unstable. So as you can see here, there is important word, BIBO. Bounded input, bounded output stability. There are another type of stability, but for us in DSP, this is important, BIBO stability. So what does it mean? So to say a system is stable, how we are going to check it? We apply a bounded input for that system. What does it mean by bounded input? Input, it has a maximum limit. So when you apply this bounded input to our system, if the output generates bounded output, the output also has a maximum limit, then this system is called BIBO stable. Okay, BIBO stable. So if you apply bounded input, if the output is increasing without any limit, so the system is not stable. For a system to be stable, if you apply a limited input, the output also must have limited amplitude. Okay, so now we have discussed how many properties? Linearity, time invariance, and stability. So if you combine the first two, we call a system LTI system. Now LTI systems can be stable, LTI system can be unstable. Now here will come another one, combination of the two. LTI system, which is BIBO stable. It's very important systems. Most engineering systems in electrical or telecommunication systems satisfy these three conditions together. They are linear, they are time invariant, plus they are stable. Combination of these three. If one of these properties is missing, it's not important for us. So a system which satisfies linearity plus time invariance, we call it LTI. And in addition to this, the system must be BIBO stable. It's very important class of system in DSP. LTI system with stability. Okay. Now, another property I need you to discuss with you is causality. Causality means it's also a very important concept which represents prediction, whether your system depends on the future output at this time it depends on which type of input. Sometimes the output at current time, at present time, depends on the past value and the present value. We call it a causal system. Okay. If the system output at present time depends on past and present inputs, not the future. Okay. Only the past and present inputs affect the output, we call it a causal system. Almost all engineering systems are causal. But in many systems like economic systems, business people, the output at this time depends on the future, right? As you know, the price at this time, price of any material, when you go to the market, it depends not only the past demand, it depends on the future demand. They are dependent on the future values to set the price of any item. That's for economics and so on. But for us as an engineers, most of our systems, our output depends on present input plus memory. Right? The inputs previously, the past inputs also affect the present output. So how we define causality? If the output at this time depends only the past and the present input, we call it causal. If output depends on the future value, it is called non-causal system. Okay. So how to check this mathematically, we'll come to that. But before that, if you have any question, you can ask. Okay. Any question?
Teacher,
Yeah.
in instability, can you explain again the last line? Instability.
Stability.
Yes, the last line.
Okay. Stability here. Sorry, let me mute first. Voices. Okay. Okay, so stability, we call it BIBO stability, bounded input, bounded output. So if you put it in words, how to define a stable system, if input is bounded, the output also must be bounded. Bounded means the signal does not continue infinitely. It has a limit. At some point, it reaches the maximum. It does not increase indefinitely, right? So it's called bounded. So, but how to check it mathematically? We use this equation. I will come to this equation after we discuss what we call it impulse response. How to check stability mathematically? Okay, we'll use this equation. I will show you this by using MATLAB. You can write small MATLAB program using this mathematical equation. How to check BIBO stability must be the summation of the impulse response. The summation of impulse response, if it is infinite or it is finite. Okay, you have to check. Let me show you one program. Here, when you see this program, we are using MATLAB to determine whether a system is stable or not. So in this program, you can see at the last, we are writing a program called summation of absolute value of H, impulse response, right? If this S is it finite or infinite? To check stability. you see this last program? S is equal to summation of H. H is impulse response. Okay, so that is the point you will find here. Summation of H. Is it infinite or finite? You have to check it. So when you write this program, and summation of H, how much answer? 14.87. It is not infinite. It is finite value. So the system is stable. Okay. If you get infinity, the summation of H becomes infinity. The system becomes unstable. This is how we are going to check using MATLAB, or you can check it by mathematically, whether the system is stable or not. But the definition is BIBO. For bounded input, if your system gives you bounded output, it is a stable system. So here, when we discussed in chapter 3, chapter 4, when you take a system, it must satisfy these both 4 conditions. It must be linear, it must be time invariant, it must be stable, and it must be causal. It must satisfy both these 4 conditions. If a system outside this, it needs a very different advanced method of processing with what called advanced DSP. You will discuss this type of systems in master's level. As I told you, when you go to your master's, the 4th semester, you will get a course called advanced DSP. There you will see how to process systems which are not linear, systems which are time variant, systems which are not stable, systems which are non-causal. But in this course, we limit ourselves to systems which are linear, time invariant, causal, and BIBO stable systems. Any question?